This video, Sine Application Part A, goes through the first half of solving an example sine application problem. The second half of solving this problem is in the video called Sine Application Part B on my YouTube channel. Here's the problem I will be solving. You go out to a dock. After you have been there for 4 hours, the water is at low tide, which is a depth of 5 feet. After an additional 6 hours, the water is at high tide, which has a depth of 35 feet. Write a sine equation expressing the depth of the water in terms of time. So this problem is asking us to create a sine equation that models a specific situation. In order to find this specific sine equation, I must first graph what the sine equation could look like. Because the problem says to express the depth of water in terms of time, I know that on my graph, time will be my x and depth of water will be my y. So now, I'm going to draw and label my axes. So my x-axis is time, and my y-axis is depth of water. If I look back at the problem, I see that they used hours for time and feet for depth, so I can add that as well. Now, I need to add some points to my sine graph. A good place to start in sine equation word problems is finding a minimum and a maximum point. The problem states that after 4 hours, the water is at low tide, which is the lowest the water can go, and the depth of the water is 5 feet. Since this is the lowest depth the water can go, it is our minimum point. So our minimum point is 4 hours, 5 feet. The problem then says that after an additional 6 hours, so 10 total hours in our time when you add the previous 4 hours, the water is at high tide with a depth of 35 feet. Since this is the highest depth the water can go, it is our maximum point. So our maximum point is 10 hours, 35 feet. And now I'll plot these points. So 4 hours, 5 feet is our minimum. And 10 hours, 35 feet is our maximum. Now that I have a minimum and a maximum, I can figure out where more points are on the sine graph. So now, I'm going to find the point in between the minimum and the maximum. This point will have an x value directly in the middle of 4 and 10. The average of 4 and 10 is 7, so that will be the x value of this point. The y value of this point will be in the middle of 5 and 35. So it is at the average of those two numbers, which is 20. So another point on our graph is 7, 20. Now, I want to find one point to the left of the minimum that is at the same depth of 20 as the point I just found. To go from the middle to the minimum, it is 3 units to the left. If I then move 3 units to the left of the minimum, I will be back where the depth is 20. So, a point I can add to the graph is 1, 20. Now, I want to find one point to the right of the maximum. To go from the middle to the maximum, it is 3 units to the right. If I then move 3 units to the right of the maximum, 3 units to the right, I'll be back where the depth is 20. So, another point I can add on my graph is 13, 20. And now I can connect the points into a sine function here. And I have just graphed a whole period of this specific sine function. To see how the rest of this problem is solved, watch the video called Sine Application Part B on my YouTube channel. If you found this video helpful, please go ahead and hit the like button. And also, please subscribe to my channel if you haven't already. And as always, thanks for watching.